So I will just start my screen share here. Okay. So welcome to What's Up Over Edmonton for the month of January and the brand new year of 2023. My name is Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada Edmonton Centre. We show the Queen Elizabeth Planetarium because the original plan was to have this session live there. I don't really think that's ever going to happen, so I'm going to have to find a different picture to put up here. But anyway, we call this What's Up Over Edmonton because the skies here in Edmonton at 53 degrees north latitude are quite a bit different than what's portrayed in a lot of the popular astronomy publications, like Astronomy, Sky News, Sky and Telescope. And the example I always use is this is July 5th, 11 o'clock in Toronto, and the constellation Scorpio is above the horizon completely at this time, as is most of Sagittarius next door. In Edmonton on July the 5th, the most we ever see of our friend Scorpio is just the top bit here. We never see the bottom, we never see the tail and the stinger. It just never gets above the horizon at our latitude. Most of the information I use comes out of the Observer's Handbook. This is the 2023 edition, and it is put out by the RASC every year. And it is 352 pages of just about any information an amateur astronomer or observer could ever want. So what do we got in the sky 2023? It's 2023 and there's still no Soylent Green. And I just put that in there because if you've ever seen the movie Soylent Green, it's set in the year 2021, and Soylent Green was all the rage. It's one of the first movies to actually talk about climate change. And even though it was made, I think, in 1974, but they didn't mention it as one of the reasons the world had gone to hell. So we've got Jupiter and Mars, brilliant in the evening sky. So long, Saturn. Hello, Venus. I was talking to Ed before the meeting started, and I spied Venus out the kitchen window between the first and second period of the World Juniors tonight. Then I went outside, had a look, see if I could spot Saturn in the twilight sky, but I couldn't quite make it out just yet. Just wasn't dark enough. Earth is at perihelion. That happened today at 9:17. That is when the Earth was closest to the sun in its orbit. We've got planetary conjunctions, got a few of those this month. And we have a winter comet. So I'm going to go and start the planetarium portion. And as always, I've pre-recorded it. So we'll get going with that. Let's start by going over the sunrise and sunset times for the month of January. This morning, the sun rose at 8:49. It set at 4:25. And astronomical twilight ended. That is, the sky became truly dark at 6:38 p.m. On the 31st of January, the sun will rise at 8:20. It will set at 5:14. And night will begin at 7:16. So daylight hours are getting longer after the solstice on December 21st. I'm going back to daylight over our Arctic hellscape that we're living in right now to point out that today at 9:17 in the morning, the Earth reached perihelion. That is, its closest point to the sun during its orbit. And as I've explained many times, it's the tilt of the Earth that causes the season, and it has nothing to do with our distance from the sun. Let's look at the evening planets. Now, technically, Mercury is still in the evening sky, but it is so low on the horizon after sunset, it's impossible to see. So we'll go with Venus. This is 5:15 tomorrow, and it is just above the horizon. You would need a very clear horizon looking to the southwest to see Venus, but it would be visible to the naked eye, assuming there isn't a lot of haze on the horizon. If you looked at Venus through a telescope, you would see it is in a very full gibbous phase, as it is just come out from the other side of the sun. It is still quite far away from Earth. As it gets closer to the Earth, the planet will grow in size, but its phase will shrink to a half and then a crescent, and then completely disappear as it passes in front of the sun and moves into the morning sky. As we move up the ecliptic to Saturn, Saturn is getting very low in January. On this day, it's going to set at 7:54. By the end of the month, it's setting at 6:30. So it's going to be pretty much lost in twilight by the end of the month. And the view of Saturn through the thick haze near our horizon is not going to be very pleasant. It's going to be, you're not going to see a nice clear picture like this. You're going to see something more like this. And that's through a telescope, obviously. But we're not completely done with Saturn. For through the month, as Saturn sets lower, Venus gets higher and higher in the sky. And they come together. And on the 22nd of January, Venus and Saturn will be less than half a degree apart, less than the diameter of the full moon.
But they'll be behind a cloud.
This is a simulation of how they'll appear. Yeah. There's Saturn there, the much brighter Venus down here. Well within the eyepiece view of just about any telescope, you can see Venus and Saturn together. Now this is a simulation at 5:30 on the 22nd. So they're about 7 degrees above the horizon. So if you have a clear horizon to the southwest, you should be able to pick this up. Naked eye, definitely with binoculars or with a small telescope. The next day, on the 23rd, we have the moon joining. And there we've turned on the labels. Okay, moving up the ecliptic, we come to Neptune. And it is a binocular object, at least. And in a telescope, it will appear as a blue disk. It's up most of the evening through January. On the 6th, it sets at 10:51. And on the 31st, it's setting at 9:12. So it's well placed for early evening viewing throughout January. And in a telescope, you can look for its big moon Triton. There it is up there. And there is its label. And like all other moons, it does move around from day to day. Moving up the ecliptic, we come to Jupiter. And there it is there. It's well placed, like Neptune, for viewing in the evening. At the beginning of the month, on the 6th, it's setting at 11:39. On the 31st, it's setting at 10:25. So it's well placed for early evening viewing throughout January and into February. And of course, we can always watch the dance of its 4 big moons. And there we have the labels. On the 6th, they're all on the same side. And of course, through the day, it changes every day as the moons orbit the big planet Jupiter. Continuing up the ecliptic, we come to Uranus, looking like a light blue or aquamarine disk in a small telescope, and you can see it with binoculars. You can actually, if you're in a very, very dark site, see it with your naked eye if you know where to look. And it's up all evening at the beginning of the month. On the 6th, it sets at 3:53, and by the end of the month, it's setting at 2:15 in the following morning. And following the ecliptic, we come at last to Mars, which was has been the star of the show all through December and into January. Mars is going to start to fade quite a bit throughout the month of January. It is up all night for all intents and purposes. On the 6th, it's setting at 6:28 the following morning. By the end of the month, it's setting at 501. But its magnitude, its brightness is going to change. On the 6th, its magnitude is minus 1.02, and by the end of the month, it fades to minus 0.26. So it is getting dimmer as it moves away from us. And of course, it's also getting smaller. And viewing it in a telescope, you will notice a difference in the size of Mars as the month continues on. But it's still bright and close enough to see surface features on the planet through a telescope. So don't miss out on this. Otherwise, you got to wait another 26 months before it's close to us again. And that leaves Mercury. By the end of the month, it is just peeking over the horizon at the end of the month. This is the morning of January 30th at 10 minutes to 8 in the morning. And you can see it's just peeking up over the horizon. You'll need binoculars and a very clear horizon to the southeast to be able to see it. This is half an hour before the sun comes up. Now tonight, if it's clear outside after this, you go out, you'll see a 12 and 3/4 day old moon. So it's just about full, passing through Taurus, not too far from Mars. Now, there was a quadrantid meteor shower last night between the 3rd and 4th. That was the peak of that shower. There may be a few stray ones tonight, but the moon pretty much washes them all out. So maybe we'll talk about that next year. And as I've already mentioned, on the 23rd of January, the moon is near Venus and Saturn. On the 25th, it's near Jupiter and Neptune, actually kind of in between them, making a kind of a squash triangle. On the 28th, it's near Uranus. It actually occults Uranus, but it's not visible in our part of the world. You have to be on the other side of the Atlantic to see that event. And on the 30th, it's very, very close to Mars. Now, I hope you all saw the occultation of Mars and the moon last month. There is actually an occultation of the moon and Mars, but it's not visible in our latitude. You have to be down in the southern United States to see that. But they will be fairly close together. In this view, which is 7 o'clock our time, they're just a little bit more than a degree apart, which is twice the width of a full moon. At 10 o'clock, let's just change the time here. There we go. They are less than half a degree apart. So if you use Mars as your guidepost, if you will, you can actually see the moon moving past it on this night. So if we go to 11, it is swept by. Still very close, but it's something to see. It would look really cool in a telescope. Not quite an occultation, but it's pretty close. Close as you're going to get. We have a visitor in the sky in January, a comet, which may or may not reach naked eye visibility. It will be visible in binoculars and in a telescope. So let's just zoom out here. Oh, I've zoomed out a bit too much. And there it is. This is from the 30th, the same night the moon and Mars are so close together. This is comet C 2022 E3 ZTF. And on the night of the 30th, it is located between Ursa Major, the Big Dipper here, and Ursa Minor, the Little Dipper. There's Polaris there, the North Star. There's the zenith straight overhead. So it's fairly high up in our sky. Let's just turn this view around a bit here. So there it is on the 30th, almost due north. As David Levy, the famous Canadian comet hunter, has said, comets are like cats. They have tails and they do whatever they want. So this one may be a good comet. I don't think, some people are saying it might brighten up to naked eye visibility. They're not expecting that it'll be another comet Neowise from a couple of years ago. But, anytime there is a brightish comet in the sky, it's cause for excitement. And certainly you will be able to see it in binoculars and, of course, in a telescope. And it's always best to get out of town to look for this guy. Now, I've set the time for 11 p.m. for this simulation, so it really starts to pop into our sky around the 11th of January. And if we just, it comes up between Hercules and Butes, although there's Hercules here. You can just see his arm or leg sticking up over the horizon. And a bit of Butes here. The bright star Arcturus is still below the horizon at 11 o'clock. But if we just follow this guy as it rises through the month, through Draco, passing the bowl of the Little Dipper, and into February. Here is it, February 1st. And it starts heading south. On February the 10th, it's passing fairly close to Mars. We don't know if it'll still be visible back then, but you never know. I mean, that would make a great picture as it passes through Taurus. And then as we go into March, it's fading and heading into the southern sky. So that's something to look forward to. It's always nice to see a comet. And the winter sky is full of really bright stars. They even have something, an asterism called the winter hexagon or the winter circle, which starts at the top with Capella, goes down to Aldebaran, the Eye of the Bull in Taurus, sweeping down to Rigel, the knee of Orion, going to Sirius, the brightest star we can see from Earth, in the constellation Canis Major, the Great Dog, up to Procyon, in this one line, which some people thought looked like a dog, looks more like the bone, but another bright star, and then up to Pollux, the bright star in the constellation Gemini, and then back up to Capella. So we have this circle-ish hexagonal shape. And at this time right now, you can add Mars to the circle of bright stellar objects in the winter sky. And there are lots of deep sky objects, nebula and clusters to see in the southern winter sky. This is a list of the Messier objects that one can see. And here are some of the bright NGC, New General Catalog objects in the southern sky. An arm of the Milky Way runs past Orion, and there are lots of sights to see within that arm. So I think that's about it right now, and we'll continue on, and I will ask if there are any questions. So, well, first off, if Alistair, if you got anything to add?
Yes, I do. Just a little bit about the comet. One of the cool things that happens from time to time, it's all about geometry, and I'll see if I can actually just hang on a sec here. When I write my astronomy magazine stuff, well, let me back wait just a little bit. I have essentially a little bit of foam, but it's colored. It's like, think of it as a pizza wedge. And as comets orbit in their elliptical plane, the fan tends to be in the same flat bit. And as it moves in the 3D space, and as Earth orbits the sun in the 3D space, sometimes what ends up happening is this thing will go edge on as the Earth punches through the orbital plane, and then it pops out the other side. So you'll sometimes you just sort of see this thing that goes boop, and it often only takes a day or two if we're going that way as opposed to sort of diagonally through it. But sometimes what ends up happening is we get, let's see if I can do this way. Yeah, we're actually, sorry, I want to flip it around. There we go. Okay, there's our pizza wedge, the center of the comet. The coma is the bright white bit. There's the green gas tail, and then there's the dust tail out this way. And when we punch through, if the things are just dead on, what we end up getting is a spike. Let's see if I can get out of the way here. A spike, and we get essentially the comet's head right in the middle, with dust tail going up and the gas tail pointing down, and this whole bit that the dust spreads away from the sun. Briefly, it looks like you've got a tail and an anti-tail, and so this is happening on the night of the 22nd and 23rd of this month, was as we punch through. So the comet will, or from our perspective, will appear to sort of go edge on and out the other side, and briefly we'll get this double tail, one of them sunward pointing. It looks like it's sunward pointing, but in 3D space it's actually pointing away. But the geometry makes it look like, oh yeah, the sun's down here. So looking very, very much forward to seeing that transformation. And with any luck, we'll get a few clear nights in there to check that out. And so even visually, we should be able to see a sort of a stubby fan go edge on and then back into a stubby fan again.
That's great. Thank you very much. Are there any other questions, comments, Rotten Tomatoes? So, all right, we'll carry on with the moon. Oh, before I start, I know some of you guys tuned into the intro to stargazing, and that ended. So for some of the months I do this, I'm going to try and incorporate some of the stuff from Intro to Stargazing, which came out of this Explore the Universe book that I sent away for. So that's what I'm going to do for this first month. So we'll see how that goes. So let's go with the moon here.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month.
Okay, first thing up will be the full moon on January the 6th. And in January, the full moon is known as the wolf moon, also the stay home moon, the quiet moon, the moon after Yule. There's also some indigenous people's names called the severe moon and the center moon. So, and there's other names for the full moon in January, but that's just a few of them. So moving along, third quarter is on the 14th. The moon is new on the 21st. And as it is the second new moon after the solstice, it's also the Lunar New Year, most popularly known as Chinese New Year. And this year, it will officially get going on the 22nd, just because of the way the calendar is in China at the time, but and it'll be known as the Year of the Rabbit. And then first quarter is on January the 28th. So, like I said, I was taking some stuff from the Observe the Universe workbook, and although what I'm going to talk about isn't actually in the book, the moon section is pretty scant, and it talks a lot about the lunar marea or the lunar seas. So I thought I'd have a little fun and talk about the man in the moon. So this is a picture from Les Voyages dans les Lunes, a 1902 French short directed by Georges Méliès. And it was loosely based on Jules Verne, From Earth to the Moon, where they shot 3 people in a shell out of a cannon from Florida, and they went to the moon. And there is the unfortunate moon getting a spacecraft in the eye. Now, the man on the moon is an example of pareidolia, which is seeing an image in random patterns. An example would be the sleeping giant in Thunder Bay, or seeing Jesus or the Virgin Mary on a piece of burnt toast. The man in the moon is the most common example of pareidolia, excuse me, involving the moon in European and North American cultures. Other cultures see other things like mice or rabbits. It's just a couple of the things people see. And of course, they don't see it in the Southern Hemisphere because the moon is upside down in the Southern Hemisphere. But in the Northern Hemisphere, we see the man in the moon. So the man in the moon is made up of lunar marea, or seas. And these seas are giant flood basins that flooded with magma billions of years in the past. And so the features we see in the man on the moon are the right eye is the Mare Tranquillus, or the Sea of Tranquility, right there. Mare Imbrium, or the Sea of Rains, for the left eye. His nose is the Sea of Vapors, or Mare Vaporus, and the mouth is Mare Nubium, or the Sea of Clouds, and Mare, I don't know, Coginian, whatever, the known sea. I'm not sorry, I never took Latin. So that is the man in the moon. And I, just from my own experience, when the moon's full, I have a tough time seeing the man on the moon, just because it's so bright. But I find it's more obvious just a day or two after full moon in the waning gibbous phase, and he's quite apparent then. So also from the Explore the Universe book, I took the constellations of winter, and I'm going to talk about Orion, the hunter. So this is the star field where Orion resides. There is Orion there. It's probably one of the most recognizable constellations. It's certainly the most dominant constellation in the southern, or in the winter sky. And there is a depiction of Orion, Orion the hunter, with his shield, an upraised club, his famous belt of Orion. There are many legends of Orion, not just in Greek culture, where we take most of the names of the constellations from, but in cultures all over the world. This constellation, because it is so prominent, has all sorts of stories attached to it. But one of the Greek stories is that Orion, the great hunter, went to Crete and hunted with the huntress goddess Artemis. and her mother Leto. And he was so enthusiastic when he was hunting that he declared that he would kill every animal in the world. Oof. Sounds like the Trump brothers. Gaia, the goddess of the earth, got so angry, she sent a giant scorpion, which killed Orion. And upon hearing the news of his death, Artemis and Leto asked Zeus to put their fellow hunter in the sky. So Zeus agreed and turned Orion into a constellation, as well as the scorpion that killed him. And he put Orion in the winter sky and the scorpion in the summer sky, so they would never meet each other again. And this is a picture I took of Orion. I took this with a film camera some years ago, and it's pretty approximate, from a dark site. This is a pretty approximate view is what you're going to see with Betelgeuse and Bellatrix and Safe and Rigel. There's the belt. There's the sword of Orion with the Orion Nebula here, this little fuzzy guy right there. So here's the names of the main stars. There's the 4 corner stars and the 3 belt stars are all fairly bright. They're all brighter than third magnitude. And so starting up at the top, we have Betelgeuse, which the distance to Betelgeuse has never yet accurately been determined because it is so bright. It's about 540 light years away, but I've also heard it's 600. I've also heard it's 400. So I just took an average of what I read and came up with 540. Bellatrix next door is about 250 light years away. Going down to Rigel, it's about 865 light years away. Again, that's one where they're not quite sure how far away it is. I've heard it's 1,000, 1,200. So we picked 865, and then Safe down here is 650 light years away. And the belt stars, they're actually further away than the main stars. This guy here, which is Elnatak, is 1,260 light years away. The middle star of the belt, Elnilim, is 2,000 light years away. And the guy in the corner here, Mintaka, is 1,200 light years away. The sword of Orion contains the Orion Nebula, also known as M42. And it is a star-forming region. It is the brightest star-forming region that we can see from the northern hemisphere. There's numerous other nebulas in Orion, but some following the Explore the Universe book, I'm not going to talk about them. I talked about them when I did Orion back in 2021. So the Orion Nebula, or M42, is a star-forming region, and it appears as a fuzzy star in binoculars, and a telescope shows it as a cloud. It's about 1,500 light years away from us. It's about 24 light years across, and it's made up of dust and gas, mostly hydrogen. And infrared telescopes have shown proto-planetary disks and new-formed stars within the clouds, stars that we cannot yet see because they're inside the molecular cloud that they were formed. Now, these typical images you see in the books, like the last one here, show color. And even this picture I took with a film camera shows the Orion Nebula glowing red with the color of ionized hydrogen, because the film can see ionized hydrogen, as most digital cameras can also, but our eyes can't. If you look at the Orion Nebula through a telescope, it's going to look like this. It's going to look gray, and it might have a tinge of green in it, depending on how big your telescope is. Now, what is lighting the nebula is right here. There's 4 stars there, and it's called the trapezium. It's a 4 tightly grouped together stars. They're fairly new. There's actually 6 stars there. A couple of these are double stars. But through a telescope, you can see these 4 stars. You can see these trapezium, and these are fairly young stars. They're maybe only 1 million years old, or maybe not even that. Maybe a few 100,000 years old. So they're new stars, freshly formed within the Orion Nebula, and that's where we'll leave it today. So we'll go on to space history. So this is the part where I talk about an event that happened in the past that not only occurred in this month, but whose anniversary year is divisible by 5. So this year in 2023, we'll be looking at events that happened in years ending in a 3 or an 8. So we're going to start December 6, 1957. And this was the launch of America's first satellite, Vanguard 1. It's part of the International Geophysical Year, which ran between 1957 and 1958. The US and the USSR were working on satellites to launch sometime in the year. And President Eisenhower, who was always leery, he was the one who actually termed the phrase military-industrial complex, even though he was a military man. He was a supreme commander in Europe during World War II. He was leery of military involvement in the project in space. He wanted a civilian project. But after the launch of Sputnik 1 and 2 by the USSR in October and November 1957, there was intense pressure in the United States to launch its own satellite. The sooner the better. So on December 6, 1957, with the launch being watched by millions on television and in person, Project Vanguard was ready to send a small, very small, it was about the size of a grapefruit, satellite into orbit. But this satellite was actually quite advanced for its time. It had numerous instruments on it. It was solar powered. It was very advanced. So let's watch the launch of Vanguard 1. So, unlike the Soviets who did everything in secret, this was broadcast live on television, and it was quickly dubbed in the press Flopnik or Kaputnik. The Vanguard satellite actually survived. It came off the top of the rocket and rolled under a car parked near the launch pad. They found it later on. So, the Eisenhower administration bowed to pressure and brought in the military to get something up as soon as possible. And so what they did, they tapped the U.S. Army's Ballistic Missile Agency, or ABMA, to do this. And they would use a modified Redstone rocket, which was a medium-range missile developed to carry nuclear weapons by Dr. Werner von Braun and his team in Huntsville, Alabama. And so the Redstone part is this bit here. And it was fitted with 3 solid fueled upper stages. And you have the 3 stages here. This is the 2nd stage. This is the 3rd stage. And then the satellite itself would have a small motor on it too. The Redstone was a direct descendant of the V2 rocket that von Braun worked on for Germany during World War II. The Redstone would later be used to launch America's first astronaut into space in 1961. So Explorer 1 was designed and built by the Jet Propulsion Laboratory in Pasadena, California. JPL completed this job in less than 3 months. And there's the Redstone sitting on the launch pad there. Oh, there's a model I built of the Jupiter C with the Explorer 1 sitting on the top, and it's gantry. And here, I'm blowing my own horn, I know. And this is a picture I took outside with a electric kettle sitting beside it to generate this steam cloud. And I lit it because I was going for this look here in my photograph. Anyway, Explorer 1 was designed and built by JPL, and it was a tubular shaped satellite. It was not very big. It was only 203 centimeters long. It was 15.9 centimeters across, or 6¼ inches. And it weighed only 14 kilos. The primary instrument in Explorer 1 was a cosmic ray detector, and it was designed to measure the radiation environment around the Earth. And this was provided by Dr. James Van Allen and his team from the University of Iowa. Also on board were internal and external temperature sensors to measure the temperature in space, both inside the satellite and outside, and also a couple micrometeorite detectors. It carried a low and a high power radio transmitter, and it was all powered by batteries, and sent its data back through these 4 antennas. There was no tape recorder on board, so all the data had to be received in real time. And here are the 3 principal people who worked on this thing, holding up a model of Explorer 1. This is Dr. William Pickering, of the Jet Propulsion Laboratory, who designed and built this thing. This is Dr. James Van Allen in the middle, who put the cosmic ray detector in the as a primary instrument, and Dr. Werner von Braun, who designed and built the Jupiter C that launched it. And you can see a model of the Jupiter C sitting right here. So Explorer 1 entered a looping elliptical orbit that took it as low as 354 kilometers from the Earth to as high as 2,515 kilometers above the Earth. Made one orbit every 114, almost about 115 minutes. It would make one orbit of the Earth, and this is a artist representation of the satellite in Earth. These black and white stripes on it were for thermal control. The micrometeorite detector detected 145 impacts during the course of the mission. However, it was the results of the cosmic ray detector that are what's best known about this mission. At the time, the instrumentation reported the expected cosmic ray count of about 30 counts per second. And they knew this because they used to, well, they still do, send up sounding rockets, which are solid fueled rockets that pop up 100 or 200 miles above the Earth and then just come right back down again. They don't have enough power to go into orbit, but they still send sounding rockets up to take these quick measurements of the environment. So they found the expected cosmic ray count of 30 counts per second, but at other times it would show 0 counts per second. Dr. Van Allen observed that all the 0 counts were reports from an altitude of more than 2,000 kilometers, while passes at 500 kilometers and below would show the expected level of cosmic rays. And they theorized, and this later turned out to be correct, that when it was up at these high altitudes, that the instrument was being saturated by a very strong radiation from a belt of charged particles trapped in the Earth's magnetic field. And the existence of these radiation belts were confirmed by another U.S. satellite launched 2 months later, and they became known as the Van Allen radiation belts in honor of its discoverer. Now, I say the stuff of many sci-fi nightmares because I'm old enough to remember watching The Outer Limits in the early 60s. And there were a lot of shows, and I'll have to say, when I was a kid, The Outer Limits scared the hell out of me. But there were a lot of shows involving space travel, going into the Van Allen radiation belts and coming, and the astronaut or crew would come back as some sort of mutated monsters. I even remember seeing a book about the early moon program when they were still working out the flight plan for Apollo, where they thought, well, we can't fly through the Van Allen belts because of the radiation. Maybe we should fly up through the pole and go around them. But of course, that would involve a tremendous amount of fuel. But it turned out, the Apollo missions flew so fast through the radiation belts, it really wasn't a problem. The batteries on Explorer 1 drained, and it made its final transmission on May 23rd, 1958, and it remained in orbit until March 31st, 1970, when it re-entered the Earth's atmosphere. So I have a little news, a newsreel of the time here.
At Cape Canaveral, Florida, the Army's Jupiter C rocket is readied for America's second attempt to launch a space satellite. No relation to the IRBM Jupiter, this is a rebuilt Redstone, a 200-mile missile carrying, instead of a warhead, 3 stages of solid fuel booster rockets and the Explorer, a 6-foot bullet only inches across, crammed with electronic gear. 30 pounds of payload. This close-up of the United States edition of Sputnik was made at a press conference with leaders of the scientific teams, Dr. Werner von Braun, Dr. James Van Allen, and Dr. William Pickering, a 3-way collaboration between private industry, academic science, and the military. Jupiter C stands poised on its launching pad. The hours-long countdown approaches 0, a moment of enormous tension, for every missile launching is still an experiment. Any one of tens of thousands of things can go wrong with catastrophic results. But all that can be done to assure perfection has been done. The moment is at hand. The countdown reaches 0. Some 3 minutes later, Explorer is in orbit, broadcasting to the world its coded scientific data. Cosmic ray intensity, meteor impact, solar radiation. These are the dry facts that will help carry man ever farther into the age of space.
Well, there's a newsreel of the time, and if any of you ever saw my news from space newsreels I did for our meetings, that was kind of what I was going for. That kind of panicked, excited in the voice. You'll notice, I don't know if you noticed when that close-up shot of the rocket taking off, that the top part was spinning, and that was done, they would spin it up to keep the thing stabilized and pointed straight once it's separated from the main rocket. The same way rifling in a gun spins the bullet to stabilize it. So, Heavens Above is a great source of information, and if you want finder charts for the comet, that's the place to go and look it up, and anything else. Just put in your location, and you can print a star map for your very location at to now's time or whatever time you want. Next What's Up is going to be on Wednesday, February 1st at 7:30. Next regular meeting of the RASC is on, next Monday, the 9th at 7:30. It will be in the Ziegler Dome at the TELUS World of Science. It's open to the public. It's also going to be on Zoom. And the link is on our website. And it's it's kind of a businessy meeting. It's our annual general meeting where we will introduce our new council and vote on a bunch of money motions, but then there'll be a members presentation after. I don't know who we're getting, but it's always interesting to hear what our members are doing. And with that, I will say thank you. And if there are any questions, I can try and answer them. If not, I'll make something up.
Jeff, I was wondering, I thought that the Webb satellite was within 250 million years of the Big Bang. And I'm kind of surprised that they can't tell us how old some of these stars in Orion are.
Well, they've got a
Exactly.
rough age of them, but they don't have an exact age. The problem is, well, I was talking about distance, and it's because they're so bright, and they're also stars like Betelgeuse are variable, so its brightness changes. And like the Gaia satellite, which is determining a lot of accurate distances now, has trouble with bright stars. They can only give it an approximation, a range. It's somewhere between this and this. So that's why. As far as age goes, well, we know enough about stellar evolution. We can have an approximate idea of how old a star is. Like we know our star is about 4.5 billion years old right now. Betelgeuse is younger because it's more massive, and more massive stars burn their fuel quicker and don't last as long. So Betelgeuse might only be, 1 billion years old, possibly. So the small red dwarfs are the ones that last the longest. So the big massive stars go through their fuel so fast, they just burn out fast. It's like live fast, die young, and leave a good looking corpse. So
Okay, thank you.
anything else?
Just a
Alistair?
comment, Jeff, in Chile, they don't call that constellation Orion. They just call it the Three Marias.
Oh, yeah.
The three stars in the belt.
Uh-huh.
I'm not sure what the story is behind that, or if it's common in all of South America or just Chile. I don't know all that.
Okay.
Yeah, I was just told that, well, a decade or two ago.
Yeah.
But
Well, yeah, I know it's like even the Cree people who live here, they have different names for it and different stories. Like when I did Orion back in 2021, I have this book of Cree legends that Wilfred Buck wrote, and so I use some of those stories. And Orion in those stories is either a good guy or he's a bad guy. I mean, it's the same constellation, but they have two different stories where he's this, he's a real bugger, right, in one of them, and the other one he's helping mankind do this, that, and the other thing. But yeah, in the Disney film Moana, I don't know if you ever saw that, there's a song in there called We Know the Way, and it tells about the Polynesian people sailing from island to island and using the stars to navigate. And in one scene, the captain of the ship or whatever, he's holding his hand up like this, and he's lining up with Orion. You can make up the constellation. You can see the constellation in the sky. Of course, it's upside down because they're in the South Pacific from our point of view anyway. But when I see stuff like that, I tend to notice it.
Yeah, I have a book here for the Inuit sky, and that whole thing that you do here, where the sky here is different from Toronto sky. Well, the Inuit sky is even also more different than the sky we have here, and so essentially the bottom half of Orion is cut off because they're so far north. It depends how far north, but essentially even the belt stars can be sort of fairly low, or they're such short duration that they don't play a big role in stuff. And so it turns out in quite a few of the northern legends, you have Beetlejuice and Bellatrix as elder and essentially grandfather and grandson, and as they go across the sky together.
Yeah, there's different legends all over the place for sure. I spend the whole year just telling Orion stories, I guess.
But I think it's also just really cool from that northern perspective, where it's like, oh, like the like Scorpius, would never be that thing from here, because the stinger is completely missing. So it would never occur to you to call it that.
Well, no, it looks more like a tree or something, really, or a tea,
a shrub,
a shrubbery. Neat. Yeah.
Cool. Jeff, I'm not sure if you can hear me or not. My name's
Yep.
David.
Yep.
Yeah. Good. Right on. The question I do have is, will we be able to see? I think you may have said it in your talk about what's happening in January, but will we be able to see Mercury at all with the naked eye this month?
Probably not. When it comes up in the morning sky, it's really, really low, and on the 30th, that's the greatest western elongation. Let me double check. I think it was I think that's why I picked the 30th to show. Oh, that's February. Mercury, greatest. The furthest distance it gets from the sun is on the 30th. It's 25 degrees away from the sun, but the ecliptic at that time is pretty shallow, so it would pop up, like half an hour before the sun comes up, and the sky is pretty bright by then. So you could probably find it with binoculars if you have a clear southeastern horizon, but I really doubt you'll be able to see it with your eye.
Okay, yeah, that's good. I think it was about would have been July, maybe August. One morning for a walk, and I saw it, and with binoculars, of course, and it just tickled me. It was like, wow, that's Mercury. It just makes a hair stand up on the back of my neck to think that you can actually see those planets when they're so close to the sun. It's like,
when the ecliptic is high, it's actually pretty easy to spot if Mercury happens to be cooperating and being, in the sky at that time. It's. I mean, I can see it over my neighbor's house across the street some mornings, at certain times of the year. But the ecliptic has to be at a fairly steep angle to see it. When it's at a shallow angle like it is going to be at the end of January, it's a tough target for sure.
Yeah, no, that's amazing. Even just today, riding my bicycle home from work, and I'm looking over my shoulder because I ride towards the east, and I'm looking like, there's Venus, and I'm like, hey, I just had to stop and just watch to see how fast it moved with the horizon, and it's like, oh man, it's amazing.
Just looking at the handbook here, and it says for Mercury, the best evening view for the northern hemisphere is the first half of April. So the end of March into the first half of
the ecliptic's really quite steep at that time of year.
And so this our evening April, or March, April, May for Mercury, those are our really good times. And so if we've got an elongation in April, as we do here, for about 10 days it'll be dead easy. And you're just like, oh, how come I've never seen that before? Because it's never that dead easy that frequently. And then, we won't get another good evening apparition until, either December or January of next year. We do get elongations, but then what ends up happening is that the tilt of the ecliptic just goes shallower and shallower. So it may be okay from the Caribbean, but not from here in summer. And then our best morning apparitions are always sort of October, November.
Wow.
And
No,
again,
thanks.
it's if the timing is right and you've got another bright planet or something like that, it's like bam. Oh, no problem at all. But at
Yeah,
other
that's good.
times and especially the way Mercury with the way it for the evening apparitions in spring, it sort of pops out from the sun as a full disk, and then sort of hangs for a bit, and then comes in between the Earth and the sun, and it just goes into a sort of really thin crescent, really fast, and its brightness just plummets. And so it's just like easy, easy, easy. Oh boy, it's gone.
Right. What is the orbital period of Mercury? I forget.
88 days.
88 days. Yeah.
Yeah, it's quite fast.
That's why he's the messenger. He's quick.
Yeah.
Yeah, every now and then it's just like, why did they give it that name? And it's like, oh, it all kind of makes sense.
Yeah. No, I love your presentations. These are fantastic. It's an educational moment of everything from Roman history to being able to look outside and see what we're looking at every night. I love it. I can't believe that there's not more people that are observing this kind of stuff. And it just blows me away. Like, it's right there. Like all of that's
so easy
magic.
to get at.
Yeah. Anyways, thank you very much for the presentations.
Oh, thank you. And as always, this is recorded, so I'll clean it up and put it on YouTube, and probably be up in a day or two. My wife's sister's blowing into town tomorrow, so I don't know if I'll have time for that, but for another royal visit.
Friday morning, not quite the scene behind you, Jeff, but the full moon is essentially going to split the towers from in a couple of mornings, as seen from Strathern Crescent on the south side of the river, just uphill from the Muttart Conservatory. There's a place called Strathern Crescent, and from that on place Friday morning, the full moon will just go right in between the towers.
Okay. Is that near McNally?
No, McNally is farther north.
Okay.
This is if you head east along 98th Ave and you go up the hill, you'll hit the roundabout. You stay right, and you'll end up coming back, westward a little bit. And
Oh, okay. So go right instead of left if I was going to McNally. Yeah. Okay.
Yeah, left to McNally, right. Yeah, and there's a few benches on there, and it's in this case the best one will be the far bench just before Strathern turns back onto and becomes Scona or 99th. I always mix those up.
And that's on the 6th, huh?
Yeah.
Oh,
Yeah,
okay.
Friday morning will be the best one for that.
Oh, okay. Cool. All right. Well, if there's nothing else, I will say thank you very much for joining us tonight, and we'll see you February 1st. And clear skies, keep looking up, and if you come out to our meeting on Monday, come say hi. We'll still have calendars for sale, right?
Yes, calendars.
We still have calendars, yes. Okay. Okay,
Thanks.
great. Thanks very much. Good night. Thanks, Alice.
Good night.
Thanks, Jeff.
Thank you. Thanks, everyone.